morning children, and welcome back to your chemistry class. Let's talk about some general methods of preparation of alkenes, right? So let us begin with the first method, that is to prepare alkenes from the partial reduction of alkynes. Okay, to prepare alkenes by partial of alkynes. Okay, so a mixture of alkyl and hydrogen when they are passed over palladium catalyst, right, which is supported by calcium carbonate. Let's see the general reaction first. Mixed with hydrogen, okay, in the presence of, what did I say, palladium, also supported over calcium carbonate, right? I hope you all can see it is calcium carbonate, and it is poisoned with lead acetate. When it is poisoned with lead acetate, we obtain alkene, that is our CH double bond CH2. This is your alkene that we obtain. So let's take an example. Say if I use ethyne, so CH triple bond CH, when mixed with hydrogen in the presence of the catalyst palladium, which is supported over calcium carbonate, right, and it is partially poisoned with lead acetate. So what are we supposed to get? From your ethyne you will get ethene, that is CH2 double bond CH2. I hope this method is clear. Okay, next let us come to the second method, that is preparation of alkenes from vicinal dihalogen derivative of alkene. From vicinal dihalogen derivative of alkene. So over here, when dihalogen derivative of alkene, it is warmed with granulated zinc, right, in the presence of methanol, then your alkene is obtained. So let us look at the general reaction first, that is CH, this, and if I take this, and this is a different substituent and this is a different substitute, and it is a halogen. So let me take a halogen over here, and they are heated with what? Granulated zinc in the presence of alcohol. Which alcohol did I say? Methanol. Then we are going to obtain alkene, that is R CH double bond CH R dash, right? Plus we are also going to get another halide. So let's look at one example over here. If I take 1,2-dibromoethane, that is CH2 and Br. What is the name of this? 1,2-dibromoethane, right? When this is treated with granulated zinc in the presence of methanol, it is heated, then we should get the corresponding alkene. So what is that corresponding alkene? We will get ethene, that is CH2 double bond CH2 plus ZnBr2. With zinc, this bromine will combine to get zinc bromide and we get our ethene. So I hope these two methods for preparing alkenes is clear to you. Let us come to the third method, that is from alkyl halides. Okay, so over here alkenes, they are prepared by dehydrohalogenation of the alkyl halides, right? So the alkyl halides, they undergo beta elimination. They undergo beta elimination from the alkenes by which method? By dehydrohalogenation. Okay, so let's look at one general method, that is your RCH2CH2X. So what is this? Your alkyl halide in the presence of alcoholic KOH, it is going to give us alkene, that is RCH double bond CH2 plus KX plus water will be given out, right? So let us look at one example over here. Always remember when I said beta elimination. So over here you will see this is your alpha and this is your beta carbon. So elimination of this beta carbon takes place over here. Okay, so let's take one example like CH3, CH2, Br. If I take bromine, so this is your alpha carbon and this is your beta carbon, okay, which on heating in the presence of alcoholic KOH, it is going to give us what? CH2 double bond CH2 and what else? This potassium will combine with bromine to form potassium bromide and water will be given out. So for a given halogen atom, remember the ease of dehydrogenation, it is like this. Tertiary, it is more than your secondary and least is that for your primary compounds. Okay. Now understand over here the Sisyphus rule as well. This is important. So according to this rule, the highly substituted alkene, that is the alkene having less number of hydrogen atoms on the carbon double bond carbon, it predominates due to its greater stability. What did I say? According to this rule, a highly substituted alkene. Now, which is a highly substituted alkene? The alkene having lesser number of hydrogen atoms on the carbon-carbon double bond. Okay, it predominates due to greater stability. Right, so let's take an example over here like CH3, CH2, CH, Br, CH3. I hope you all can see this. So over here, this is your alpha carbon, this is your beta and this is your beta carbon. Okay, this in the presence of your alcoholic KOH, on heating it is going to give us two alkene products. What are they? That is CH3, CH2, CH double bond, CH2. This is called as but1ene plus, it is also going to give us CH3, CH double bond, CH, CH3. This is our but2ene. So but1ene, but2ene, both the products will be given, but we will observe that but1ene, it is only 20% yield, and but2ene is actually your major yield. That is, it is around 80% yield of but2ene takes place. Clear? Thus we can say that this shows Sitzeff's rule. Let's do the fourth one, that is the Kolbe's electrolytic method of preparing ethene. Okay, so when an aqueous solution of potassium succinate is electrolyzed between two petroleum electrodes, then we obtain ethene at anode, right? So let's look at the reaction. CH2COOK, CH2COOK. What is this? This is, as I said, potassium succinate, right? So this is going to give us which ions? It is going to give us, this is your succinate anion, succinate anion plus your potassium cation. Clear? So this is the ionization. Now let us see the oxidation at anode. Oxidation at anode. So over here, your succinate anion, that is CH2COO, CH2COO will give away 2 electrons, and it is going to form the succinate free radical, right? Plus 2 electrons, and thus further this succinate free radical, this is your free radical, okay? This succinate free radical, it is going to give us ethene, CH2 double bond, CH2, and carbon dioxide will be given out. So over here, decarboxylation takes place. Okay, I hope this is clear to you. Let us understand how to obtain alkenes from alcohols, okay, by acidic dehydration. By acidic dehydration. Okay, so over here also we are going to see beta elimination, right? So let's see over here, like if I talk about primary alcohol, so CH3 CH2OH, over here in the presence of 95% sulfuric acid at 440 Kelvin. So now over here, if you see, this is your alpha and this is your beta carbon, right? So what are we going to obtain? CH2 double bond CH2, that is your ethene, plus water is given out, right? Now this was your primary alcohol. Now let's look at the secondary alcohol. For example, CH3, CH, CH3OH. So now if this is your alpha, this is your beta, and this is your beta carbon. So over here at 60% H2SO4 and 373 Kelvin should be the temperature, then we obtain CH3, CH double bond, CH2. What is this? This is called as propene, and water is formed. And now let us look at the tertiary alcohol, that is CH3OH, CH3CH3. So now let us see all the carbon atoms. This is your alpha carbon atom, this is your beta, this is your beta carbon, and this is also your beta carbon, right? So what is the name of this compound? 2-methyl propane 2-ol, which is also your, this was your secondary, and this is your tertiary alcohol. At with 30% H2SO4 and 363 Kelvin, it is going to give us CH3C double bond CH2CH3. So what is this? You get 2-methyl propene plus water is formed. Clear? So these were how to obtain alkenes by alcohols by the acetic dehydration method. So that is all for today. We have done the general methods of preparing alkenes. In the next video, we shall start with the physical properties of alkenes, and we'll also discuss about the chemical properties of alkenes. Thank you.